Hello, hello, hello. I am back again for another day of Advent of Dreams. Day 10. I am excited that I have made it this far. So, that means we are, over a third of the way there, if you want to count it like that. Given that there are 25 days. If I complete this, I guess I will be a clean 2/5 of the way there. So I'm pretty excited about that. And without further ado then, because I'm starting really late, I think I should just get right into it. So let's pull up Advent of Code here and see what problem we have in store for us today. Day 10, Cathode-Ray Tube. You avoid the ropes, plunge into the river, and swim to shore. The elves yell something about meeting back with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritized getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be of much immediate use. Unless, that is, you can design a replacement for the device's video system. It seems to be some kind of cathode ray tube screen and simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. I've been talking in previous days of Advent of Dreams about how I want to avoid having stuff depend on clocks and specific cycles and exact frames, and yet here I am. It's unavoidable. Start by figuring out the signal being sent by the CPU. The CPU has a single register, X, which starts with the value 1. It supports only 2 instructions. Add X, V, takes 2 cycles to complete. Oh my goodness. After 2 cycles, the X register is increased by the value V. V can be negative. No-op takes 1 cycle to complete and has no other effect. The CPU uses these instructions in a program, your puzzle input, to somehow tell the screen what to draw. Of course, I have to make my own little, CPU in Dreams for today. Of course I do. Consider the following program. No-op add x3, add x minus 5. Execution proceeds as follows. At the start of the first cycle, no-op begins execution. During the first cycle, x is 1. After the first cycle, the no-op instruction finishes execution. At the start of the second cycle, during the third cycle, x is still 1. After the third cycle, the add x3 instruction finishes execution, setting it to 4. Yeah. Maybe you can learn something by looking. God, why do they have to give me such a big program, dude? Consider the signal strength, the cycle number multiplied by the value of the X register during the 20th cycle and every 40 cycles after that. Why? During the 20th, 60th, 100th, 140th, 180th, and 220th cycles. For example, consider this larger program. The interesting signal strengths can be determined as follows. During the 20th cycle, register X has the value 21, so the signal strength is 420. During the 60th cycle, register X has the value 19, so the signal strength is 60 times 19 equals that. 1800, 2940, 2880, and 3960. The sum of these signal strengths is this. Find the signal strength during these cycles. What is the sum of these 6 signal strengths? And of course, the actual... Wait, is that literally the same program? No, it's not. It is a slightly different program, but of similar length. Boy, it's gonna suck if I have to encode literally all of this into my dreams program. I'm gonna start with something much smaller. Much, much smaller. I mean, naturally, I'm first going to start with this. It'll probably be hard enough just to get that working. But in a sense, this is actually like a simpler, purer version of what I've already been doing in so many of these problems. So, you know, it might not be so bad. Let's get this stuff on screen for y'all. I guess we'll just start with that. Just that one tiny, tiny program, and we'll go from there. So, let's hop back over to Dreams and get this thing going. Let's make a new scene. Get right back to the old business of CPU building. God, I hate this mic arm so much. You see it just fall over, just fall out of frame. It's beautiful. Now it's gonna climb out of frame. It has exactly two modes. Either climbing too high or falling too low. There is no in between. So, I am annoyed that I have to do more iteration stuff, but I also kind of said that I was going to do iteration better. And so here I find myself at a crossroads where I get to spend some time immediately thinking about how to do a better version of this iterator thing that's been giving me problems for the past week plus. So, I have this node called iterator, which I've been using over the past, like, basically since this thing started. And what it does, if you're familiar with programming, it's basically a for loop. But what it does is you can pass in the total number of things that you want to step through. And it will output the current index that you're on. So if you want to loop through 5 things, it'll output 0, 1, 2, 3, 4. It has this use port here that indicates you may currently use this value. And it's present primarily because 0 is a valid value that you want to use. There's this next thing, which is just the inverse of use, basically. It alternates use, next, use, next, use, next, use, next. So that whenever it's in the next state, you know, first of all, not to use the value. It's sort of in the process of transitioning. And also, you can use the signal from next to reset anything in your node graph for the next evaluation. And when you've gone through the whole thing, both use and next turn off, and it outputs done. And it stays done no matter what else happens. You step it to the next thing by piping in next. You can reset it by pressing reset. It basically is just a general purpose step through this many things, and it's kind of busted. So somehow it just has problems. Also, the logic in here kind of doesn't make any sense to me anymore. And in general, it occurred to me that the counter exists. I really should have thought of this before, but counter do exist, and I should really make use of it probably instead of the memory cell thing that I currently have in here. Now this is something that allows me to store a value, like a numeric value, just within the dreams graph without needing a variable for it. However, adding to it is weird because you have to do this loop back around and add something and power on the something something. Hey, you know what exists in Dreams already? Counter, which stores a numeric value and can be incremented and has a target value. This is so close to what I need already, and I'm just so mad at myself that I didn't think of this before, but I was too stuck in my very like programmer brain ways to even remember that, hey, this node exists. However, what it doesn't do is the like use next kind of thing, which I still find very valuable for sequencing the more complicated logic that I've been doing. So what I want to do to start is see if I can build a better version of my iterator thing using a counter. What I may do is just copy at least the nodes here over to a new microchip that will be sort of iterator Mark II. Because the overall interface of it I like. It just doesn't really work very well. And I think I can keep the same interface while making it more reliable by banking on an internal counter. So let's pull that in. We have a counter. Now this total thing, very straightforwardly, can go into my target value here. That's exactly what I want to hit. If I want to count from, you know, if I have 5 items, then I want to count 0, 1, 2, 3, 4. And when I hit 5, I want to be done. So already this seems quite straightforward, I guess. Counter full here just goes straight to done. Simple as that, basically. Now I only want these. We'll figure out some of these later. But how did that? Is there a wire going across from there to there? Is there really? There is. Why is there? Huh. I guess so. I'll keep that wire. But I'll have to figure out exactly how to use it. Now the main thing. Naively, I would also say whenever you pipe in next, then you would increase the count. That makes sense. God, it also has reset, doesn't it? I'm really an idiot, aren't I, for not using this? I mean, there's really going to be like hardly anything else. What am I missing here? This literally is just the counter, right? All this time hold on, there has to be more to it than this. There's still this output of use, which is kind of perhaps useful, but God, I'm really gonna be annoyed when I like spent all this time debugging my iterator node only to realize that I was re-implementing the counter node. So I do think there's some value to like disabling specific outputs when we're in like the done state and that kind of thing. So there's that, but if that's really all this provides me, then like, boy, that's annoying. I could have saved myself so much time. Grab this guy. You're in use mode when you're not in next mode. That'll come over here. And when we're not done, we want to have these powered on. I mean, is this it? Please tell me this isn't it. I'll be so annoyed. Let's go ahead and grab some switches and number sliders that I can use to control various aspects of this. So we'll say that our maximum can go, we'll say that it goes from 1 to 5. I don't really deal with an iteration amount of 0, and I don't feel like debugging that. Although I guess I would want it to go straight to the done. You know what, I'll try it. You know, I'll see what happens. Let's grab a switch that can push me over to the next input and a switch that can reset. And let's see what we do here. So the output right now is 0 and we're in the use state. Then we say we're at 1, don't use it yet. Now use it. 2, don't use it. 3, use. 4, use. And then when we go next again, now we're done. I got the done output wired backwards naturally. Kind of meant for it to go like this. There we go. And now, if I keep poking next, the counter stays full. If I reset this, resetting is a little odd. You really don't want to be in the next state while you're resetting. You just don't want that to happen. I'm so annoyed. I spent how much time recreating the counter node? How much time? I mean, seriously, what was I thinking? Here's some other stuff I can do, though, while I'm in here. I can have... I think I might want to preserve some of this stuff where, like, if you reset while next is on, you get weird behavior, right? Like, this probably indicates a bug, though. So in fact, what I might do, yeah, I feel like it's actually just a bug to do that. So what I think I'm gonna do, I'm going to consolidate some of this stuff, which, you know, now that I know how much simpler my whole iterator thing can be, I'll make that logic itself a little more concise. And then I'll add what is basically debug output at the bottom. First of all, I guess I will, I want a number slider over here that shows me what index I'm on. Just so that I can always easily read that. The others are pretty clear because they light up. I don't really have to worry about that. And then down here, I basically just want to have like a selector that will indicate whether we stepped into the wrong state ever. So like, for this particular case, that would mean if reset is true and next is true. I think that just means you messed up. And I don't want to do what I did over here, which is to try to like make it wait until, like, hold the reset but wait until next is false. I think if you do this, you messed up and you're not going to get the results you expect, so better to just treat it as a bug, make the bug visible. So what this means is if reset is true and next is true, then step this over, and I'll rename this to next while resetting, which is really the bug. You don't want to do that. So if this happens, you know you messed up. Are there other sort of buggy conditions you might have? For one thing, I'm curious how it works to change this while you're counting through. You know, I could like add to it and that works, but then if I shrink it down, that just immediately makes it done. Sure, whatever. That's pretty much what I'd expect. Well, I'm real annoyed with myself for this one. Wow, I'm so annoyed. Why did I make my life so difficult? And let's see, if I now reset while next, then yeah, now that selector is in that state, which is bad thing. So good to try that, I think. Great. That's so much simpler than all this crazy pulse logic over here and everything else that I used to like make sure that I would transition cleanly into the done state. It was all right in front of me the whole time. How deeply frustrating. But oh well, it is what it is. Should be able to much more easily use this as my base for all iteration related things. Iterator 2.0. Can I like do a color pick? Can I color picker? Sad. Close enough. Maybe I should give it a slightly different color. Yeah. Or maybe I want it to be, I don't know. This is all pointless at this point. There we go. Lovely purple. Well, that's great. All that effort. Here, let's save this as its own thing. All I needed was a counter. How stupid of me. Okay, time to actually make ourselves a weird little CPU. Let's write out our program here, shall we? In typical fashion, this is going to have a selector that lets us step through everything, where basically we're going to have 3 instructions, each of which is going to be encoded in some way. And in particular, that some way, I think, is just going to be a 2-number thing, where I assume that the instructions are all going to be just like, I need one for the instruction type and one for the instruction operand. That's good enough for this problem as it stands now. If we grab our value slider here and set this up with 2 possibilities, either no op or add x, because it's the only thing this problem can do, then our first instruction is literally just this, and our second instruction would be this, and now we need an actual value. So, you know, maybe we would, I'm gonna just put this down to like negative, well, what did they have in the problem? They've got like arbitrarily large negative numbers here, really. Well, not really that arbitrarily large. They go down to like -40. For now, I'm just gonna go to -5 and 5, because I want to be able to use the sliders without typing in numbers. So 3, and then -5 on this. So that gets us our 3 instructions. Each of these is going to be powered when the corresponding state of the selector is on. And we will then output information about this. This will be num instructions. Which we will pull off of the selector's top port, that is the number of ports. We will also have the port on the way, oh wait, multiple things here. I need a port for the actual program output here, so instruction, I guess. And we need an input port, as always, for the, I could call this the instruction pointer. Use the actual computer term. Just to be cute. Who doesn't like to be cute in their programming problems? And we'll leave it at that for now. We'll call this thing input. Or I could actually call this program now. It's not just the input. It's a program. Let's start out by making a variable for this X register. And I guess now we can just, let's see, I kind of also want to make what is essentially a data table for the for the number of cycles that each instruction takes. I kind of want that to be stored out of band. So let's just duplicate this down. And there's really very little reason to duplicate now that I think about it. We're going to get rid of all those. I mean, honestly, all these two. Our value slider, though, is going to go from like 1 to 2 or 3 or something. So the no-op instruction takes 1 cycle, the addx instruction takes 2. We don't need that. Why? Yeah, there was no reason to copy-paste anything. Those are going to be our actual outputs. We need to conditionally enable these based on an input, which I can do with yonder selector. Like so, I guess. Whoa, does that work? Wait. It automatically jumped me from wire A to wire B here. That's awesome! Oh, I keep learning all these lovely little shortcuts in Dreams. Cool. We'll call this instruction, though. And we'll call this like instruction times or something. So what that lets us do is pass the current instruction. Well, we have to split apart the current instruction into the instruction type and the operand. Instruction type, what? Instruction type will go here, which will output my 1 or 2 or whatever. And this will be my operand. And at this point, then we're just going to have to do sort of a switch on all the actual instructions that we might want to actually execute. So let's see. Index is going to feed in here. The number of instructions is going to feed in here. For now, I'm going to have a manual, just a button that lets me essentially cycle the overall computer clock here. But I guess that's going to happen over here. So basically, we need another switch on which instruction we're going to run here, because each one, I guess the way that it works is we actually want to delay by the amount of time specified in instruction times, which we can do with an iterator again, I guess, even though a plain old counter would be completely sufficient for this. In fact, in this case, because it's purely a delay, yeah, we're literally just going to do a counter. We're going to set the, oh no, not that. Wait, what type of, why did it go to there? There we go. That's our target value. And then, let's see, how does the problem state it? At the start of the first cycle, the no-op execution instruction begins execution. After the first cycle, the no-op instruction finishes execution, doing nothing. So, I think that basically when this thing is high, that's the case in which we might step to the next cycle, and when it's low, we would actually sort of execute the result of a particular instruction. What I think I'll probably do is make a like execute instruction chip here that I can just power on and off. Instruction typing coming here. This will switch on everything. And then, you know, this whole thing can execute when this thing goes low and we're at the end of our counter, when the counter is full. Also, when that happens, let's see, I'm going to have an output node on this thing that's like done. We did the result of that instruction. Which I have so that I can out here step to the next instruction. Which I'm going to do with a wireless transmitter like I usually do to avoid cycle issues. We'll call this one next instruction. Grab a wireless receiver over here, set it to the whole scene. Set it to listen on next instruction and pipe that into next. There might still be some weird issues with needing to turn that into a pulse or something, but we'll figure that out. So, our current instruction is the no-op. We do that, and then when we go off, now we execute that no-op instruction, which does nothing, and I guess pipes directly to done. So that stepped us to the next thing, but also, let's see here. On next, we need to reset this counter. Okay. Now, our target value is 2 because per the instruction timings, we are executing our second instruction. We can see that we're trying to add 3. And so then 2 cycles go by, and now we need to actually execute that instruction, which is easy enough. That's literally just a power on a variable modifier with the value. And we'll add. The value is going to be this operand down here. The power is this. That added 3 to it. And then I guess also would fire us over to done. So we'll get like a single pulse of that. And now we're completely done. No, we're not. What am I doing? So let's try the whole program now. It should actually work, and we should get -2 up there. No op happens. Next instruction. 2 cycles. We add 3. Next instruction. 2 cycles. We add -5. Okay, I mean that already did it. Perfect. Okay. All right. That was already it. Wait. Oh. X starts at the value 1. Okay. I was like, how do I get -1 out of this? But it's because the problem actually specifies this starting at 1, which is easy to do because Dreams lets you do the same. Yeah, easy peasy. So, okay. Now, here's the issue. The actual program. God, I hate this. Hold on. Hold on just a moment. I need to do a little bit of work here. I'm just cropping an image on my other monitor here. Let's drop this horrible image into OBS. So here's the thing. Here's the actual program that they give me for this first day. And they want me to input all that into Dreams. They want me to do all that. That's so gross. It's so long. Like, oh my goodness. Like, how am I supposed to do that? And unfortunately, I kinda... I'm gonna take it one step at a time here, I think. I'm gonna input like 20 or so instructions because the problem wants me to check the value of the register during the 20th cycle and then the 60th, 100th, 140th, 180th, 220th cycles. I can do that. But inputting all this is, oh, such a pain. Oh, such a pain. It's so long. But what choice do I have? What choice do I even have? Let's start to make some room here. So, what do we have at the start of the program? Already we have not a no-op. I'll tell you that much. So we're going to add, and at this point the number is just kind of get too wild for me to actually bother dragging them on a slider, so we'll just do this. Add 15. Oh, this is gonna be so good. -15 -11, and then like a gazillion more of those. actually worked this time. It actually laid them out reasonably. I'm so happy. The only minor issue is that one slightly different gap, which I can fix like so, and we're good. Wow, it's a Christmas miracle. 6 minus 3 5 minus 1 minus 8 13 4 and then a no-op. Convenient that I have a no-op hanging out down here. And convenient that I counted exactly right. So I do unfortunately have to hook all these up to this, which is the thing I most love to do. But I am so happy that Dreams automatically steps me to the next port of the selector whenever I do this. That is such a great quality of life thing that I had no idea about before. And that was 10 instructions, right? Cool. So that's the whole first selector worth. And then I also just have to okay. That's a huge quality of life change to be able to input them that way at all, though. I just had no idea about that before. So if I were to step through this and get the value on the 20th output. So this is where I actually need like another counter. We'll say that my target value is 20 here. I'll just take a look at this. Every time we toggle this on, we'll increment it. And then we'll just look at the value after 20 clicks of the button. So we can see it filling up here. Counter is now full. The value is 36. And the website tells me that during the 20th cycle, it has a particular value. Shoot, what was it before? Well, let's start over. Yeah, it has a value of 21, so the program's working. During the 20th cycle, register X has the value 21, so the signal strength is 20, cycle 20, times 21. The value equals 420. So cool. That works. What we need to do is basically like output. I want like 5 different values to be saved that are like the signal strength. What I think I can do I'm gonna kind of make my life easy here, and I'm gonna make some kind of, well, let's right now start to think about how we're going to present this scene. kind of want this to be... Let me grab my snowy scene here. The snowy rocks that I've been using for most everything. Yeah, so we'll just put that, you know, somewhere in the scene here. Now, how does I want to set up a scene that looks kind of nice here. So let's see. I need to look on the Dreamiverse for a, like, just for some sort of gadget. I want to do like a, what if I search for like walkie-talkie or radio? We got sounds. That's kind of an awesome sound. That's kind of awesome, actually. I wanna look at this in more detail. Oh, that looks good. So the text here, they got the massive text displayers. Oh, I forgot you can use those as sort of notes. Wonder what's controlling the, like, what is doing the thing behind that? Ah, this. Clever. The thing is, I kind of want to replace the screen with stuff of my own, or have some wires coming out or something, right? Like, I want the fiction of the problem is that I have like a busted communications device of some kind. Why all the handwritten buttons? I kind of like that, but also like, yeah, this one will do. This one will do. I just have to get rid of the text on screen and replace it with my own stuff. So let's see. This thing's gonna be sort of laying broken in the snow, basically. I'm kind of surprised. wanted to have like a cracked look on the screen. That doesn't exactly look right. What if I search for crack? TV, yes, exactly what I was looking for, yes. Just like a cracked screen effect that I can just put on stuff. What? What are you? I'm sorry, what? What? What are you? Is this like a painting thing? What are you? Almost what I want. I should maybe look at what the other... That's just like the exact same thing. Okay. Tell you what. I'm having trouble aligning these, and I suspect that rotating everything the way I did was not a good idea. So I'm going to put these on the grid and try lining them up sort of at their proper size first. Because yeah, now this, like, they're both perfectly aligned now. What are you? What are you? Like, I don't know why it insists on poking through that way. When I go into this... Now I understand. Now I understand. It's a screen effect. I am understanding. So it's a look cursor. What is that, and how do I make it not that? There we go. Yeah, well, so now the problem is that that one was sitting down there. But now it should be fine. The only issue is that one piece sticking out over there, which I think I can pretty easily, well, also that one piece sticking out over there. How do I erase in paint mode? Huh? Can I like resize? Can I like, what are my options here, man? I actually don't think I have much choice here. That'll do. How do I actually now? How do I change the colors? If I want them to be why, huh? Why you gotta be so weird, Dreams? Why you gotta be so weird? Why are you going behind there? Oh my god. You're painting back there. No, I want you to... Can I change colors, please? Can I change colors, please? Dreams, please. How do I do this? Wait, that's it? Huh? Huh? I mean, maybe it's good enough. I wanted to put it kind of to blue and give it a slightly bluish tinge here. Just to look more convincingly like a broken screen, you know? I think that's not bad. That'll do, I think. So let's group those together and go put it in the ground like I wanted to. So, what's tonight's challenge? Hi, Entropy. Sorry I missed your message. Tonight's challenge is basically to make a computer. But the code part is like already done, which is wild. It was really easy. Also, I took another crack at the iterator thing and realized that a counter is basically 95% of what I need, and I only needed like a couple little logical things to get exactly the interface that I wanted. So all that iterator stuff I was doing before was basically useless and just making my life difficult for no reason. In any case, what we have here is a weird little like CPU where it like goes through and executes these instructions, and then each instruction takes a certain amount of cycles to complete, and then when the instruction finishes, it like adds the corresponding amount to this X register up here. And I have to do something that basically like the fiction here is that you have like a broken communications device and you're trying to like reverse engineer it and add a screen of some kind to it. So I think I'm going to I'm trying to set up like a fun little scene for this. So if I can like get a decent like CRT display. Also, this CRT effect thing, doesn't Dreams have something like that built in? Why can't I, like... Why does this have next to no effect? That makes me sad. Ah, interesting, okay. Would there be any way to, like, if I want to, let's see, can I get rid of... Let's see, I kind of want to get rid of the fleck color on this, on the screen. And make just like a basic screen that I can put some text on. So are the fleck colors are somehow different here? Oh yeah. Maybe. Aha. Oh, I see. It was glowing, a glowing screen behind some non-glowing flecks. Or is it the other way around? Is outer properties the like fleck color? Basically, yeah. What if I want to like turn flex off, basically? I'm not actually sure how to do that. Assume that would be style mode here or something. That's kind of fun. Can line it all up. But what if I want to basically... Oh, is that only doing this mode? Yeah, okay. No. I just kind of get rid of flex. It's very fun to set all this up, but I don't know. Right. Confusing myself again with this stuff. Why is it not? Oh no, there we go. Why is that now making it so naturally line up? Okay, well, whatever. Let's see, what if I actually made it like... Maybe I would like some effects on it, actually. That looks kind of nice. And then I can put some text on this screen that shows off what I'm doing. So now I think when we reach a certain point, we need to like list out the signal strength. I kind of want to show the like name of the instruction that we're running, which means that I get to make a text displayer here. That is in the scene. Pretty sure I'm gonna need to allow rotation. And let's set up something that'll say no-op. Nope. Let's get a sufficiently computery font on it. Oh. Oh, man. Some real chunky fonts in here. Huh? It's very weird. That'll do. Well, it's either that or the like weird that one. And that one's real tempting. I kind of want to see what that looks like with horrible green text. Horrible glowing green text. I might have to decrease the brightness of the computer screen a little bit. Oh, is sticker mode gonna actually work this time, or is it gonna look like crap? It looks like crap! Why does it? Why? Oh no, sticker mode actually works great when it when I turn the glow on. I wish I had realized that before. Okay, well, sticker mode for the win then, apparently. But let me actually make it a little bit chunkier so that it's easier for me to splat it on there as a sticker. Why the box is drawing over there, I cannot fathom. But if this is the command that we're running, I'll need a few, like, sort of duplicated, I guess, but well, let's see. I should actually probably make this say add X first, because I need to line that up with a number displayer with very similar properties for the old operand. This thing, we're going to display, let's see, I'm going to just punch in 15 for now, just because that should let me line it up reasonably well. You need to go to font 10, and then, let's see, do negative numbers render nicely? They do. Set it to left align, get rid of this, get rid of this. Oh, actually, did I get rid of the shadow? Did. Cool, cool. We'll make this green the same horrible green. Why are you not? Because that's not the text color anyway, so it didn't matter. Or maybe something is just really freaking annoying here. There we go. Allow rotation, please. Go all stickery. And set you on the monitor. Oh no, they do have slightly different hues, don't they? Well, that's annoying. Wow. This is so hard to control. It's so fiddly. Ah. It's so finicky. That'll do. This is just slightly wrong. There, that should be lined up a little better. Okay, and what I can do now is we will duplicate this text displayer for no op. Takes up the exact same amount of space, that's cool and all, whatever. We're gonna duplicate this instruction times thing because it's actually useful for why do I bother duplicating anything? There's no point. There's no point at all. So when we're looking at the no op instruction, we're going to power on one of these things, otherwise we're going to power on a different one of these things. You know how it goes. So this one's no op, I think. This one's add X and this thing. And the number into the number displayer here is going to be that. So why are you saying 225? Why would that be what you say? Because this was on 15 and so now it's modulating. Get out of here with that. That's not what I want. Okay, that's working. I also need, let's see, something that will print out the X register plus the signal strengths. So, let's see, I guess I'll start by just duplicating down the text displayer for add X, and I'll just make it say like X equals. And we'll duplicate down the old number displayer. And that one we'll just pass in the value of X. Did it go into modulate mode again? Gosh dang it. Okay, let's play this. That's pretty nice. Okay. We need our signal strengths here now. And this is where I actually get into like the main part of the problem. So I guess about time. I'm distracting myself with fun visuals tonight because the problem was easy. Let's see here. Seems to be working. Slow down the clock for a second. Save that again quick. I do want to check this grades and effects, or I guess I want to see. So I had searched for CRT, right? And there are all these like oh yeah, that's like a. How does this like work? Oh, grade and effects. But can you put a grade in the world? Can you like... No. No, apparently not. it'd be so cool if you could, though. I mean, imagine if you could, though. But fine. But fine. We won't bother. This will be sufficient. Can the number displayer have animation? This is a random question. Can it animate a number typing out? No, I don't think so. That's fine. Okay, so let's see, what else do I want out of this? I need basically, the problem has me getting values for on the 20th cycle, signal strength on the 20th cycle. So, excuse me, goodness sakes. I need to have some, I guess, just separate variables and things. And I'm gonna move these down here. So when we count up to the 20th cycle, we want to actually compute this signal strength and set a variable that I guess we will call, I'll call it S20, just to make my life easier when typing. The signal strength on signal 20. The signal strengths can go up above 1,000, which means that I should really set this to something that can go above 1,000. So this is S20. We're going to set S20 to a thing once we get this counter full. And that is going to be used to power some more visualizations on the screen here. So I guess that probably means just duplicating this stuff and doing it more. So this is S20, which means that I can do, I'll just call it S20. That seems cool. S20 equals this is less than ideal. How make wider? Why no handles on for make wider? There we go. Okay. I need a node for powering on S20. No, I don't. Haha. You can just wire into power here. It's as easy as that. Such that now, once it ticks up to cycle 20, I never actually said what the value would be. Brilliant. I need to calculate my signal strength down here, which is just the cycle number In other words, the value, I kind of need like one Uber counter that we'll just let this be the Uber counter. That'll never, ever, ever fill up. But when that equals 20, then we would power this on. And in the meantime, the signal strength is going to be computed via this number times times the actual value of register X. So easy enough. I'll just grab a variable modifier that gets the value instead, because that's convenient and cool. So that's simply X times that. X times our cycle number. Easy to compute. Then we can just have all of our S20 through S whatevers ready to go. Is S20 supposed to be 6300? It's absolutely not. Where did you... Oh my god. Unreal how I have to change that every single time. 420. Indeed, that is the right answer. Cool. Okay, that's good. I can easily add in the other things, but the problem is that I have so much more program to add, which is deeply annoying, but I feel like I have to do it. I'm gonna be here all night just punching in tedious stuff. All right, this one's gonna be S40. Actually, I need to duplicate this up here first. So this one, it's S60 actually. There we go. I just wanted this to show up so that I could move this down without, and make sure that everything visually lines up. It's not gonna ever be like perfect monospace, but it'll be pretty good. That'll do. And S60 will be set when this thing equals 60. I didn't change that. Also, I think I should really, well, it's because I don't have enough steps of the program in there, and so it's just like repeating the last one in this really jank way. It's just stuck on ADX 15 and it just stays stuck that way. And it just is maxed out. Okay. Well, it won't take me long to add even more of these. Again with the crappy lineups. Dreams, you should fix that. Let's see, I need strength at 60, 100, 140, 180, and 220. So S20, S60, S100, right? That's right, yeah. S140, S180, and S220. Got to change all these text displayers too. S180. And S220. And let's start moving these down. Heck with it. We'll just display all of them. I kind of need to see all the lines in order to line everything up. Oh no, it's not gonna quite fit. Haha, no. Well, I can shuffle some stuff around, I think. I knew this would happen. I knew it. Also, that font is in monospace. It's slightly off, and that's kind of sad. I wonder, actually, I could very easily change the font. Something else, but I kind of don't think I'm gonna find a good monospace, so we'll just stick with what I have. I like the look of this font. There we go. That works. That looks pretty good. I just need to hook up a bunch of power things again. My favorite. Okay. $60, $100. How I love this. 140. 180. And it should change which variable it's touching, so that's 100. 140. 180. 220. What we should see now is as all this stuff ticks by, eventually 20 cycles will have elapsed. Or, yeah, 60 cycles will have elapsed. I kind of want to change this counter. The counter is clearly not going to go above 300 in this example, so. Keep on pulsing. Wait. Oh, I didn't wire this in. I knew there was something I forgot. It wasn't setting. And why? Just want to see them all appear. That's the main thing. Hooray. And also, how do I make it, when this is done, I need to like power off the clock. Yeah. Well. Now I guess all I need to do is painfully input like a gazillion more instructions into here. We've already filled up a whole selector. So time to do it again. Which I'm not really looking forward to. Because here's the thing. I have to duplicate down this entire chunk, which Probably I should turn into a microchip of its own. Yeah, that's gonna be the only semi-reasonable way to do this. And it's not even that reasonable. Anything I'm missing? Knew it. Now anything I'm missing? We kind of need to like build a bunch of these little programs and have an outer thing that sort of handles all the stepping for us. Stepping from one selector to the next. This is gonna suck. We need the sort of meta selector on the whole thing. And we need a big old wide calculator on this whole thing. That's going to contain every program's worth of instruction counts. And then this, we need to, well, first of all, we need that other selector, like I said. There, that's how I can do that. Haha. I've cheated the system. In order to pick which of these I need to divide by 10 and round down. That is what feeds in here. But then also, for what I feed in here, I need to do mod 10. Remainder, there it is. So that now should actually step through two, Wait, what? Oh. Should also really wire this up. Although that doesn't seem to be helping me any. The result is 10 here because of abject garbage. Yeah, that's right. I forgot about that. I forgot about this. I don't actually want to power these microchips directly. I want to have an active port on the inside, which just activates the output port at all. Yeah. Yeah, I only wanted to control that port. Fine, very well. Okay, so now if I run this, it steps to the next one. And if I pull up both of my sort of chunks of program here, oh, right. Yeah, I think that's working now. Excellent. Because now I can see for a while it's outputting it here, now it's outputting here. All good. All good. What are you? How many no-ops are just hanging out down here? We'll tidy that all up. Shove some stuff closer together on this graph. And then get to the unpleasant business of just doing incredible amounts of redundant work. Tedious data entry. But what else was I going to spend my evening doing anyway? So, where had I left off? Going from the top of my screen now. We will add -1, 5, -1, 5. Why? You gotta do this. -1. 5. How many of those have I done? -1, 5, -1, 5, -1, 5, -1, 5. And then, or no, this one is supposed to be -35. And then 1. Was that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, I messed up somewhere. -1, 5, 3, 4, 5, 6, 7. Crying out loud. This is stupid. Is that right now? Oh yeah, it is, because this is another add-x in this world. And this one goes to -35. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more instructions. Tick by. I love this. There we go. accidentally did a dumb, but it's fine. Let's go again, another round. 1, 24, -19, 1, 16, -11, 2 no-ops, 21, and -50. Is that another 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, what did that end on? The -50. Getting into Noop down here. Oh, I just realized an unpleasant thing. Let's see, I'm gonna duplicate this down. That's gonna be sort of my prototypical chunk of program because it has all addexes. So now I can Noop stuff out and delete things and not worry about having to re-add those things later. -3, 9, 1, -3, hello, 8, what is going on here? It won't collapse. 1. I think it's that I'm pressing the left bumper too soon. 5. And this is a no-op. Was that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Keep it going. Noop, 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 noop. -36. Noop. 1, 7. Noop, noop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many more? How many more? Noop. 2. Six. Noop. Noop. 5 noops. One. And noop. Are there really more than 100 things in this program? Oh gosh, that means that I'm gonna have to like step out even wider over here. Oh no. Oh no. That's fine. It's fine. It's great. It's fine. Nope. You know what, actually? I'm gonna hook up all of them and all of these and all of these. And all of these. And we're gonna run it and see what I get for some of these other values. To be clear, what I should expect now is that during the 60th cycle, or just actually at the value 19, we should get 1140 as the signal strength on S60. Thank goodness, it's working. All right, back to data entry. This is absolutely the most riveting stream I've ever done. So let's see here. Nope. Then 7. 1. Nope. Minus 13, 13. Seven. Nope. One and minus 33. Was that 10? 1, 2, 3, 6, 7, 10. Let's keep it rolling. Nope, nope, nope. Two. Nope, nope, nope. 8. And nope. That was another 10 easy. 1, 2, 3. One, 2, 3, 4, 5, 6, 7, 8, 9. Wait, no, it's not. What the hell? No, 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 no. Oh no. I missed that one. Nope, nope, nope. 2. Nope, nope, nope. 8. Nope and -1. I have to be so vigilant here or I'm going to make one tiny mistake and that's going to be it. 1, 2, 3, 7, 8. But I've got a process. Trust the process. 2. One. Nope. 17. Negative 9. One. One. Negative 3. This is the cruelest example input they could have possibly given me. It's just sadistic. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like over 100 lines. Hey, Abdallah. You have tuned in to the most tedious thing I have ever done in Dreams. Trying to encode a list of like over 100 numbers into Dreams so that I can run this programming challenge that was designed for you to be able to copy paste the whole list. But what must be done must be done. 1. And nope. And 1. I hope you're doing well this fine evening. 2 noops. Negative 13. Negative 19. One and 3. Was that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. More numbers. We're making such good progress here. Look at all this. That was a mistake. Wire up all the stuff. Then all this stuff. How many, I wonder how many things a wide calculator can accept. Power mode doesn't apply in Dreams. I turned off all my channel point rewards to minimize confusion. Here, I'll do what I can for you. There. Was that powerful enough? This is the most tedious Advent of Code problem yet. Because for some reason, the example input is like 140 lines long. And I don't even get good visual output from it. This is what it looks like to run it. I have to like go line by line through this whole thing, and even then all I get out is some numbers. Here, let's see if we should get 1800. We do. The next number should be 2940, but I might run out of instructions. Yeah, oh no, I didn't run out of instructions. There's a bad number somewhere. There's a bad number somewhere in all that. Somewhere in the 100 entries that I've already done. There's a bad one. No, I was trying to be so careful. I was trying so hard to avoid this. And yet somehow I've messed it up. Somehow, somewhere, there's just a bad one. What is happening over there? Somehow instantaneously you like went through 6 different moderation states for the chat here. Oh, see, I never actually clicked that button. I don't know what it did. Thank you for testing it for me. So, here's a question. How much do I care? Because this is going to be just exceedingly painful. Let's see here. This ticker tape. You see how many I've already gone through? God, I hate this so much. It doesn't tell you until you do it or click learn more. Yeah, wow, cool. So, 1 second here. 1 second. 1 second. So, as I said, somewhere in these, like, somewhere in this first 100, there's a mistake. So, as of S40, it's correct. Or S60. Which stage of program are we in here? Okay. So, starting from here, we have a problem. There's a problem somewhere in here. So, this starts at, let's see. Hi Ziba, I am inputting, so the overarching thing that I'm doing here is I'm doing Advent of Code problems in Dreams. Advent of Code is a yearly programming challenge where there's a new programming problem each day, and you write a program to compute the answer to whatever is given. They have like example input and then one very large real input that you have to put through that's like too big for a human to go through and calculate by hand. I'm doing it in Dreams for fun. I'm having fun. What do you mean deriving Boolean logic for these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry, what? Oh, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, noop, -3, 9, 1, -3, 8, 1, 5, noop. That one seems fine. Next one. Noop, -36. Noop, 1, 7. Noop. I wonder actually if X maxed out. I should check on that. Each bar of a digit. No. I'll walk you through it in a second after I'm done, like, a little bit checking through what I'm doing here. Noop, 2, 6. Noop, 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 noop. 1, noop. Noop 7, 1. Noop minus 13, 13, 7. Noop 1 minus 33. Boy, we're looking annoyingly good so far. Where could mistake be? Noop, noop, noop 2. Noop, noop, noop 8. Noop minus 1. Still good. Two, 1, noop, 17, minus 9, 1, 1, minus 3, 11, noop. God, did I make a mistake? Did I even at all? There's only one more thing there could be a mistake in. Noop, 1, noop, 1, noop, noop. Minus 13, minus 19, 1, 3. There isn't? Well, then what is giving? Does X just climb too large? Or am I a huge idiot and X... Hold on. No, X, the bounds on X are relatively large. So let me step you through here. My way of iterating is that I just have this number ticking up and I power on one node at a time. Now what's happening is that I'm then stepping through from one microchip to the next. Yeah, that's what I'm doing. How on earth can I be getting 3080 here? It's displaying it correctly in the sense that that's the value that was set. Could there be some shenanigans? No, it's overriding. Ugh. How could it just mess up right there? You know? How is that the part that messes up? I'm baffled. And rather discouraged. Because as far as I can tell, my whole input is correct. I've wired all of this up correct. Everything's worked up till this point. All these, I mean, if I watch it go here, I can see it step through all the correct microchips, so I don't think that I've wired anything up particularly stupidly. logic all seems sound. They all have the correct setup with the active pin. Why? Why? Why are you like this? So, during the 60th cycle, register X should have the value 19. Oh, it does. That one I already confirmed worked. During the 100th cycle, it should have the value 18. And it does. Oh, that one also worked. 1800. During the 140th cycle, it should have the value 21. Why is it 22? Why? Surely I didn't mess up just one number, like... surely... One, it's minus 13, it's minus 19. Did I, like... I checked all these, though, you know? I checked them. The thing of it all is that I did check them. Is one of the, like... Is one of these numbers not wired into the right port? Like, I just am struggling to comprehend where the mistake could be when I've already looked over this whole thing, like, several times. There it is. There it is. I knew it. I knew it. That was the one that I, like, patched up differently. Aha! Aha! I found it. That's the bug. Because we were off by one. That one minus one didn't happen. Unreal. Unreal. So all the values were right, but there was a wire missing. Woo! All right, well, great. Now I can get back to the actual, you know, punching in the remaining 100 or whatever. 2940? Was it supposed to be 2940? It was. Ha! Okay, we can resume our suffering. We can replace our suffering with a more productive kind of suffering. So, I now, regretfully, must add another stage of garbage to this. wherein I divide by 100 and round down to pick which set of 100 I'm picking from. We'll just keep modulifying everything. Oh yeah, because we need another selector. Ha 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 ha. Out here, which is what this wires into. Which set of 100 are we looking at? You know, that's the question. And then this is actually what we wire in to here. This is the next stage. It's beautiful. I love it. It's so beautiful. All right. Now we can copy this to begin our next set. Isn't that great? Let's see. I'm like a little bit paranoid about Oh, this will actually work. Okay. So I can actually power on this selector and then power on this selector. And that should actually be fine because I'm not getting counts out of these selectors. I'm only getting counts out of these. I was worried about powering them down for that reason because otherwise they output 0 and then the total count doesn't include them and that's bad. But I don't have to worry about that here. You know? I just don't have that problem. I will be so glad when I'm done with this problem. So glad. So let's get back to punching in numbers. $26. Minus 30. Every day has something to make it take hours and hours and hours. Today the problem was easy, but the example input is like 140 lines. So, you know, why not? Keep me on my toes. One. Nope. 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 And minus 9. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, that lines up. We'll delete the things that were nuked. And move on to the next 10. 18. One. Two. Nope. 9. Nope. Noops are my favorite. And -1. Ah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The end is in sight. The end is in sight. Two. -37. 1. 3. Nope. 15. -21. 22. -6. And 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just a little more, just a little more. Nope. 2. 1. Nope. -10. Is my controller drifting? No, I'm drifting apparently. What did I just do? -10. Nope. 20. 1. 2. 1, 2, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just a little more. One more. One more. And it doesn't even have all 10. 2. -6. -11. Nope. So that makes 6 on this thing. Okay. Make a little room for a wide calculator. And let's see, I have so much to wire up here, just so much. this gets to wire into all of these. And all of these get to wire into this. And is it done? Is it done? Did I do it? No, because I did not change this to 100. I knew there was something I messed up. Oh, no, 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 no. Nope. Because also I am need this. All right, now. I want to see it step to this one. Okay, I think it's working. Was pretty sure I did the math right on that. 2880, that's correct. 3960, is that correct? Oh! Great. Now just a tiny, 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 tiny bit more work, and I can ship this thing. And go do something else with the fleeting few remaining minutes of my night. So now, putting all that junk away, and getting rid of that incorrect name, we need to hide the ADX15 when the program is done. So when this is done, we'll just power down this selector entirely. I meant to invert that. As always, you know, I always do this. So that should turn off when we're all done. And then we can output the total sum of the signal strength. All the signal strengths added together, 3960. Which is basically going to be, I'm just going to duplicate this down here. It'll be just one last little thing. Hello, please delete. All of the S's need to be added together here using another widened calculator. The embiggened calculator. And both of these will be powered on when done. However, oops. We're actually going to copy paste these two. This is what I meant to do. Since those two are in the same place as the add x15, which is where I want to put the sum equals whatever output. Let's start with this. Fortunately, I think I need to power these down briefly. So that I can adequately format these. Okie dokie. Wire these back up. And have these both, I need to restore the power thinger that I did before with this. There. So now it should basically just like work all the way for real this time, and I mean it. $1440 or 1140, 1800. This is tracking so far with the problem. 2940, 2880. 3960, and when it's done, the sum of the signal strengths is supposed to be 13140. Oh my god, it's the stupid modulating thing. Come back to haunt me one last time. 13140. Ha! I am back at it again, Ninja McWiz, and finally, after manually inputting, you'll never believe it, after manually inputting about 130 numbers, about 130 fake CPU instructions here, it is finally crunching the entire example data set. It is so cruel of them to give me such a long example. But I've done it, I've encoded the whole program, it runs, and all I have to show for it is numbers on a screen, just like if I wrote it in a normal programming language. This problem is just cruel. It's just pure cruelty. But it's done. The only thing that I maybe want to do now is display a wire between the two things here that I can. That's enormous. Why so big? I want like, let's see, is this just a sculpture? It is just a sculpture. I kind of want some like wires just sort of visually like running between the two that can be like blinking just for some visual emphasis on the problem here. So, numbers on a screen is pretty hype. I am pretty hyped about numbers on a screen. The fiction here is that you broke your communication device and need to like reverse engineer a new display for it. So I've set that up here. I like how it looks. Yeah, imagine a black object does not actually glow. So now, when the clock is high, we're going to use that to modulate this glow. And when the clock is low, we're going to modulate, oh no, that was the wrong thing entirely. Gotta be more careful about which thing I'm selecting here. Yeah. It's a little bit strobier than I wanted. I'll probably dim it down. That's that'll do. Actually, no, it won't. I am going to turn it down again. Nope. Ah, it looks better like this. What if I give the wires like a slight yellow or green tint or something? Or better yet, give this wire a red tint. So we got our Christmas wires going here. All right. Yeah, nope, or no op is no operation. It's a fake CPU here. So those are the two types of instructions they have: no op and add to the X register. It's a really thrilling concept for a problem. Let me set up my Well, let's see. I might actually shrink this ever so slightly. Nah, I like the framing better like this. Set up a camera, call it a day. Is this working? Am I changing focus here? Does it do depth of field? I would love depth of field on this. I mean, I can sort of see that that's the implication here, but I'm not really getting any effect. Oh, aperture. Yeah. Oh, yes. Yeah. Let's drop an ILF in the background. Maybe I'll drop that like campfire in the background that I used before. Or a few random crates for literally no reason. I like the idea of the fire because that would be all just you know, it would be dynamic. Did not mean to do that. Let's see here. Actually, you know what I'm gonna do, which is gonna be jank. Can I just pull in this entire scene? You cannot stamp scenes. Well, frick. Where's my elf? That's pretty nice. That's quite nice. The elves being down there is breaking the story. Well, I'm supposed to be in a jungle or something, so the story is not super intact as it is. Also, I want to make sure that neither of these are possessible, and I forgot to do that before I cloned them, which is just so annoying. How is my mic up there now? I didn't put it up there. It's a great mystery. Okay. Let me... There's something else I was about to do. Oh, I was gonna make it nighttime. Or just, you know, nearly. Gentle blue. Dim that down a little bit. Make the sky a little bluer as well. Sort of dark blue that feels like, or a darker blue that feels sort of like nighttime. Is this any good? This kind of just feels too blue. Oh, don't zoom in and out. No, no. That's pretty nice. Oh, you know what I think I'll do also? We're gonna dive into this and give this thing some real gentle glow. Give it sort of a static effect. It's not quite as glowy as I wanted it to be. You know what? Nah. It's just broken. Plain and simple. Plain and simple. Keep moving the camera. It's a dangerous thing. All right, well, oh, actually, we're gonna go in here, and this is where we're going to save a version so that we get a nice thumbnail on it. And just like that, I think we can go publish it. Advent of Code 2022. Day 10. 10 days down. What was the name of this? Cathode-Ray tube. Cathode-Ray tube. Publish. On the internet. Yes, 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 please. Hooray. Hooray. Let's see, I'm actually a few days behind on this. I've only got 7 on here. Yeah, wow. Let's add a few days worth to my collection here. Actually, I should probably arrange them like a calendar now that I think about it. This one is Thursday, Friday, Saturday. And then it'll be like 1, 2, 3, 4, 5. I guess let me get the rest of them in here. Need my rope bridge, and I need my cathode ray tube. I had that in the wrong place. That's day 7, day 6. This one's day 2. Where? Oh, these are just completely in the wrong order. Just not even close to in the right order. All right. I can also, I guess, put in some, let's see, can this actually say something? Like, can this say Sunday? It's kind of annoying how the whole canvas shifts around as you do this. Very much a moving target. Sunday, Sunday, Sunday. I'm gonna have Nesday in my dictionary now. Whoa. All right. That's nice. That's nice. All right. Well, that's another one in the books. I spent so long inputting data. I think the actual problem took me maybe 40 minutes, and I've been streaming for 3 hours and 20 minutes. So that's fun. Be back tomorrow. All right. Gonna sign off. See you next time.